Okay, so this lecture is a continuation of part one. In this particular one, we're talking about sampling. Okay, these next two set of problems. All right, so the first one says a botanist at a nursery wants to inspect the health of the plants at the nursery. Which of the following best describes a systematic sample of plants? Okay, um, so if we look at the term systematic sample, let's go to that. Okay. It says that the members of the population are listed in some order, then every case member, such as every fourth member, is selected for the sample until a predetermined sample size is reached. Okay, so the best one that describes that would have to be number three, right? It says the botanist takes a list of the plants and selects every sixth plant until 54 plants are selected. Okay, so the first one there, the answer is three. Okay, the second one, a host on the cruise ship wants to collect data on the time passengers spend at various activities on board. Which of the following best describes a convenience sample? Okay, well, the answer for that one is going to be number three again. The host selects the first 72 passengers who board because these passengers are easily accessible. All right, so remember, convenience sample, literally what it's saying. It's convenient, right? You don't have to go out of your way to sample the population there. All right, for part C, a city manager wants to poll residents about a park renovation. Which of the following best describes a stratified sample of residents? All right, so let's go back to our definitions. Okay, so we're talking about stratified sample. So it says the population is divided into groups, with each group made of members that share some particular characteristics, such as occupation. Then a fixed number of members, but not all the members from each group are randomly selected for the sample. So each group basically is being represented. All right, that's the key part about this, the stratified sample. So let's go to back. All right. So the one that closely um, discusses this would be number two. The city manager forms four groups of residents based on the residents' incomes. Then she selects 16 residents at random from each group. Okay, so you have the four groups, and then each of the group is represented. So the answer for that one is number two. Okay. The This one says a bank analyst wants to ask customers who have a mortgage with the bank about the customer's home buying experience. Which of the following best describes a stratified sample of customers? Okay. So remember, stratified means you're broken up into groups and each group is represented. Okay. So that one would be, for this one, the answer would be number three. The analyst forms six groups of customers based on the customer's mortgage amounts. Then she selects 13 customers at random from each group. Okay. Part B, a consultant wants to ask workers at a factory about the workers' job satisfaction. Which of the following best describes a convenient sample of workers? All right, so for that one, the answer to this one is number two. All of the workers on the second floor of the factory building are easily accessible, so that consultant selects the first 90 workers from the second floor to arrive at work on a particular day. And the last one here, a manager at a bus company wants to survey employees about the new uniforms. Which of the following best describes a cluster sample of employees? So again, cluster means um, everybody in that group. These are divided into groups, but everybody in that group is selected. Okay, so this one would be number three. Okay, the manager forms groups of 12 employees based on the departments that the employees are in. Then she selects all of the employees in five randomly chosen groups. Okay. All right, so this next column says there were 20 participants in a recent study on personality traits. After being shown four images, each participant selected the one that was most appealing to them. Okay, so this is a frequency table. So notice here on this image or image table, you have these numbers, right? The image each participant selected appears below. Complete the frequency distribution for the data. All right, so basically all you're doing here is for each image that is displayed, you're just counting how many times it shows up. Okay, all right, so for example, for image one, you would count how many times image one shows up, and it looks like it shows up 1, 2, 3, 4, 5 times. So you would write 5 for the frequency. For image two, that shows up 4 times. So 1, 2, 3, 4. So you would write 4 next to this. For image three, that also shows up 4 times. And for image four, that one shows up 7 times. So let's write that down. So this would be 5, 4, 4, and 7. Okay. All right, so let's look at part B. These images are associated with four personality traits, but not every image is associated with every trait. The table below shows the traits and the images associated with them. Okay, so the first column here talks about the trait, and then the second column here talks about the image. Okay, so the question is asking how many participants selected an image that is associated with being impulsive. Okay, so again, the question is asking how many participants selected an image that is associated with being impulsive. So, right, so impulsive, the images relating to impulsive is 1, 2, and 4. So we just count how many times those showed up. So for number one, it was 5, number two was 4, and for number 4, it was 7. So you just add those up and you'll get 16. Okay, so you'll have 5 plus 4 plus 7, which is equal to 16. Okay. It says here are the hottest recorded temperatures in degrees Fahrenheit for 8 cities throughout the North America. Complete the group frequency distribution for the data. In the distribution, the frequency of class is the number of temperatures in that class. Note that we're using a class width of 5. Okay, so in this case, so let's talk a little bit about class width. All right, so normally we would subtract this and we get 4. But in this case, in these types of tables, these frequency tables here, um, they're also including the number itself, the first number. So 103 will be the first one, 104 will be the second one, 105 will be the third one, 106 will be the fourth one, and 107 will be number 5. So that's why they're saying the class width is 5 there. All right. So again, let me write that down. So we had 103, 104, 105, 106, and 107. So that's a total of 5 numbers. So that's where they're getting the class width of 5. Okay, so that's going to be important. All right, so basically for this one, just to save us on time, right, we would just count how many degrees fall into this interval. So in this case, that would be 3 here. All right, from 108 to 112, that would be 3 again. And then from 113 to 117, that would be 2. Okay, you're just counting how many times those temperatures fall within those ranges. Okay, so let's go to our next slide. Okay, so it says 16 cyclists were each asked the number of miles they biked last week. The responses are given below. So this table here tells us the number of miles that they biked. Okay. Part A here says complete the group frequency distribution for the data. Note that the class width is 4. So again, they're counting the number itself, 0, And then 1, 2, 3 will give you a width of 4. Okay. Part B asks, construct a histogram for the data. So let's talk a little bit about what that means. So what is a histogram? So a histogram, okay, means it is continuous. Okay. That means every number is accounted for. Okay. Also, the bars touch. Okay. So again, just trying to conserve on time here. So for part A, right, we would just count how many times the number of miles fit or fall into this range. Okay. So in this case, from 0 to 3, that was 4 times. From 4 to 7, that was 3 times. 8 to 11, 4 times. 12 to 15 is 3. And 16 to 19 is 2. Okay. All right. And so the part here I want to stress is the constructing a histogram. Okay. So let's go ahead and construct that first and then talk about what this definition is saying. Okay. So the first part is from 0 to 3, the frequency is 4. So the max here is 4. All right. From 4 to 7, the max is 3. From 8 to 11, the max is 4 again. From 12 to 15, it's 3. And then the last one, 16 to 19, is 2. Okay. All right. And then we're just going to draw our bars here. It doesn't have to be perfect. Okay. All right. So, before I talk about this here, let me talk about just a regular bar graph. Okay. So you've probably seen a bar graph like this, right? This one talks about the favorite type of movie. So, you would ask people like, what's their favorite type of movie? And here they said, 4 people like comedy, 5 people like action, 6 people like romance, so on and so forth. All right. So this is a typical bar graph. All right. And notice the bars here don't touch, right? They're independent of each other. All right. So, but in this case, for a histogram, okay, notice here that the bars touch. Okay, that's what it's saying. The bars touch, right? They're not independent of each other. The second part is it's saying it's continuous. Every number is accounted for. So notice that, numbers 0 to 3, every number is accounted for there, all the way up to 19. Okay, so whether there's something in there or not, it doesn't matter, but as long as those numbers are represented. Okay, so again, that's what that means. A histograms, the bars touch, and that every number is accounted for. It is a continuous type of graph. Okay, so remember that. Okay, so here we have the hottest recorded temperatures in degrees Fahrenheit for each of the 15 cities throughout the North America. Here are the temperatures listed. Complete the group frequency distribution for the data. Note that the class width is 5. Okay, so hopefully for this one, you wrote down from 98 to 102, that was 3. From 103 to 107, that was 4. From 108 to 112 is 2. And 113 to 117 is 6. Okay. And then to draw our histogram, I just like to mark the highest number for each of the bars first. but you can do whatever, whatever is easier for you. So 3 for the first one, 4 for the second one, 2 for the third one, and 6 for the last one. Okay. And I just draw my bar graph there. Okay. All right. Okay, so this one is saying here are the shopping times in minutes for each of the 18 shoppers at a local grocery store. Okay, these are the shopping times in minutes. Part A says complete the group frequency distribution for the data. And part B, using the classes from part A, draw the frequency polygon for the data. Note that you can add or remove classes from the figure. Okay. All right, so let's first talk about the class width. So this one's a little bit different. Okay. So remember we were talking about that the previous problems, it counted the first one as part of the class width, okay? And all the way to the last number. For this one, what they're doing here, okay, for these types of problems, is they're just subtracting. So 20.5, okay, minus 14.5 will give you 6. All right, so that's how they're getting the class width. Okay, so that's different from the ones that we've been doing. Okay, so anyway, so if you're questioning that, that's how they got that. All right. So again, first part A, you just count how many times it lands within this parameter. Okay, so let's write that down. So for 14.5 to 20.5, that will be 4 times. From 20.5 to 26.5, that would be 3. And then for the next two, that would be 5 and 6. Okay. All right. Now this one is talking about a frequency polygon. Okay. So what does that mean? So remember, a polygon, it can be a regular polygon or an irregular polygon. So your polygons can be like, a triangle, right? Or a square, right? Or a pentagon. All right. And these are regular polygons. They don't have to be a regular polygon. Some of them can be, kind of irregular. So it can be something like this. All right. All right. It can be 4 sides that are not the same. Okay. So anyway, um, so that's what a polygon is, 3 or more sides. Okay. So we're going to create something similar to that. All right. And it wants us though to label each class with its midpoint. Okay, so how do we do that? So we need to create another column here. So I'm going to put midpoint. So I'm going to use a different color here. Okay. So this is going to be midpoint. Okay. Then let me erase this part. Okay, so to find the midpoint, all we have to do is add those two numbers that we have. It's like finding the average and divide it by 2. Okay, so for this one here, I'm going to have 14.5 plus 20.5 divided by 2. Okay, and that's going to give us 17.5. Right, so here I would write down 17.5. Okay, the next one, I do the same thing. So I'm going to have 20.5 plus 26.5 divided by 2. And that gives us 23.5. Okay, so I'll write 23.5 here. Right. The next one, we have 26.5 plus 32.5 divided by 2. So that gives us 29.5. And for the last one, we have 32.5 plus 38.5 divided by 2. That gives us 35.5. Okay. So let's write that down here, 29.5 and 35.5. Okay, so that's our midpoint. All right. So anyway, so let's look at this frequency table or this graph here. So on the y-axis, the vertical axis here, you have your frequency, the number of times it occurs. And then on your x-axis, the horizontal axis, you have the shopping times in minutes. So notice that you don't have enough points, right? We have 4 points here, right? 17.5, 23.5, and 29.5, and 35.5, but you don't have enough points. So that's why it says you can add or remove classes from the figure. So somewhere here in the program, like underneath, you can add another point. Okay, it's a little bit tricky to find, but it's down here on the program. Okay, so you just add another point. So that's what I'm going to do. Okay, so I'll just put it right here. Okay, because again, we need these 4 points and we only have 3. Okay, so then I'm going to write down what we just figured out. So this would be 17.5. Then we have 23.5. Then we have 29.5 and 35.5. Okay, so this is representing the horizontal axis, or the x-axis is representing the midpoint. Okay, all right. All right, so now what we do is, so for each of these midpoints, we have our frequency. So for 17.5, we had a frequency of 4. So let's put a point there. For 23.5, we had a frequency of 3. So we'll put a point there. For 29.5, we have a frequency of 5. So we'll put a point there. And for 35.5, we have a frequency of 6. So we'll put a point there. Okay. All right, and what we do is just connect the dots. So we're trying to create some polygon, right? So again, it doesn't have to be regular where all the lengths are the same. It can be irregular. So, right, so I'm going to connect the dots. Here, here, here. Okay, and at the end points here, we just snap it, right, to the horizontal axis. Okay, all right. And then what we just created here is a frequency polygon. So this one we have here is nice. Okay, so because they gave us their class width, and we just had to figure out the midpoint, okay, and the frequency. For this one, it's a blank slate. Okay. All right, and so we have to create this table from this blank slate. All right, so it says here the following are distances in miles traveled to the workplace by 17 employees of a certain hospital. Okay. Draw the frequency polygon for these data using initial class boundary of 1.5 and a class width of 8. So let's highlight that. So we want a class boundary 1.5 and the class width of 8. Note that you can add or remove classes from the figure. Okay, label each class as its midpoint. Okay, so basically we're going to be doing what we just did before, but this time we need to, do the whole table. So I'm going to have my table into 3 categories. I'm going to have the distance, the frequency, and then the midpoint. Okay. All right. So the distance, right, it says we're going to initial class boundary of 1.5. So we're going to start at 1.5. Okay. And we're going to up to, says a class width of 8. So we just add. Okay, so we just add, so 1.5 plus 8 is going to give us 9.5. Okay, all right. And then we do the next row here. So we're going to start at 9.5, then up to Okay. We're going to add 8, so that's going to give us 17.5. Okay. Then we just keep doing this. All right. Next one would be 17.5 up to 25.5, then 25.5 up to, I'm going to have 33 there, 33.5, and then 33.5 up to 41.5. Okay. Okay. All right. So now we need to count how many times the numbers, right? The miles fall within this width, class width. Okay. So again, to save us some time, the first one, and there's a different color here, is 3. The second one is 5. The third one is 6. The fourth one is 2. And the last one is 1. Okay. All right. So then the next part you're going to do yourself. All right. See if you can figure this out. All right. So you need to find the midpoint for each of these ranges and then plot your uh, frequency polygon here. Okay. On this graph. Okay. Okay. So the midpoint, again, all you're doing for the midpoint is you're just going to add the two numbers there that you have and then divide it by 2. So again, that would be 1.5 plus 9.5 divided by 2. Okay. And that gives us 5.5. Okay. So again, we do that for each of these rows. So we'll have 5.5 here, 13.5 here, 21.5, 29.5, and 37.5. Okay. All right. And again, notice we have 1, 2, 3, 4, 5. Okay, 5 midpoints, and we only have 1, 2, 3, 4 given. So we're going to have to add, right? That's what's saying we can add another class. So we'll just add another class here. And I'll just put it right here. Right? Don't worry why it says zeros, that you would have to enter those numbers in there in the program. Anyway, so let's go ahead and write those numbers. So we have 5.5. Then we have 13.5, 21.5, 29.5, 37.5. Okay. All right. And then for the frequency, we just plot them. So the first one we have 3. The second one we have 5. The third one we have 6. The fourth one we have 2. And then the last one we have 1. Okay. All right. And then we just connect the dots. Right? And then the end, we just snap it to the x-axis or the horizontal axis. Okay. And then we're done. All right. So here we have what's called a stem and leaf display. Uh, Gives the amount of money in dollars spent by the Flores family in their last 17 trips to an amusement park. Use the display to answer the questions that follow. Okay, so this is the amount spent at the amusement park in dollars. And you want to look at the key. Okay, the key tells you how to read this. So if you have 21 and it is this vertical, so this vertical line is the stem part. Okay, And then the leaf are the numbers from the left and the right side of it. That's why they call it stem and leaf display. Okay. So again, the vertical line is the stem and the numbers to the left and right are the leaves. Okay. So here it says 21 and the vertical line is 7. This represents $217 spent. Okay. So this is kind of a concise way of listing the numbers. So for example, this one here, 21, 21 and then two number sevens, that means the number 217 is listed twice. So this is 217 and then 217. Okay. The second one, if we were to expand this, it would be written as 221, 224, 228, and then 228. Okay. So again, this is just a concise way of listing the numbers. Okay. All right. So what are we trying to do here? So we're just going to read this stem and leaf plot or display and then answer the questions, right? So the first question is asked, what was the highest amount spent in the 220s? Part B, what was the highest amount spent overall? And part C, how many amounts fell in the 210s? Okay, so go ahead and see if you can figure that out. All right, so let's go over this, okay? All right, so the first one again, what was the highest amount spent in the 220s? So a lot of you guys wrote down 228, and that is correct. Okay, so 228 here. What was the highest amount spent overall? We will look at the lower, the bottom number here, so that would be 244. Okay. And the last one, how many amounts fell in the 210s? Well, we listed here is there's two of them, right? 217 and 217. So that would be 2.